Now in this section, we're going to put everything that we learned in chapter 3 so far, 3.1 through 3.4. So 3.1 to 3.4. Adding fractions, adding like fractions, adding unlike fractions, adding mixed numbers, subtracting mixed numbers, and so on. So we're going to put everything together, and of course, we're going to use PEMDAS every single time that we have different operations in the same problem. So parentheses first. What's in parentheses we have to deal with first. Now what exactly does that mean? 2 over 1 minus 2 over 3 has to be simplified until it is a single number. A whole number or a fraction in its lowest terms. Now here we need a common denominator, and if one of the denominators is a 1, clearly 3 would be the common denominator. So we multiply the numerator and denominator with 3, and what we get is 3 times 2, 6, minus 2 over the common denominator of 3, the whole squared. We have to keep simplifying until we get a fraction in the lowest term. 6 minus 2 is 4 over 3, the whole square. Double check if it's in the lowest terms, and then the next step is 4 over 3 times 4 over 3, which is equal to 4 times 4, 16, over 3 times 3, 9, and that's our final answer. Parentheses first. Now here we have mixed numbers, division and multiplication. So mixed numbers with division and multiplication, the mixed numbers have to change to improper fractions first. Always, when if it's division and multiplication, change the mixed numbers to improper fractions. 7 times 2 is 14 plus 1, 15 over 7, divided by 1 1/3, which is 3 ones are 3 plus 1, 4 over 3, times 7 over 10. So once we've changed the mixed numbers to improper fractions, then the division has to change to multiplication first before we can do anything else. Do not cancel, do not do anything unless we change division to multiplication. The minute we change division to multiplication, we flip the fraction, the one fraction, to the right of the division sign, and then this is what we get. Notice that this is multiplication, so you do not need to flip that fraction. So 15 times 3 times 7 divided by 7 times 4 times 10. Now we have to factor the expression and cancel as many common factors as possible. Now I see that there is one more common factor. I go 5 times 3 is 15, and then of course we have a 3. The denominator is a 4. I'm not going to break that down because I don't see any 2's sitting in the numerator. Times 5 times 2. Now the 5's cancel, and now that we have no other common factors, now we multiply the numbers together. 3 times 3 is 9, 4 times 2 is 8. Now again, we have mixed numbers. When it's multiplication and division of mixed numbers, we change it to an improper fraction. But when it's addition and subtraction, we could, of mixed numbers, then leave the mixed numbers alone. Sometimes if the mixed numbers are large, it's better to just leave it alone. So I'm going to leave 8 and 7/9 alone. Plus, since we're going to do in PEMDAS multiplication first, So 6 times 2 is 12 plus 1 is 13 over 6 times 3 times 3 is 9 plus 1, 10 over 3. So 8 and 7/9 plus, and let's see if something cancels. I see a 2 sitting in the numerator because 10 is 5 times 2. The 6 in the denominator is 3 times 2, and then we have another 3. So I write that down. I cancel the 2's. And now I have 8 and 7/9 plus 13 times 5. 5 3's are 15 plus 1. 5 1's are 5. 6. 65 over 3. Now I can change this. I'm sorry, it's a 65 over 9 because 3 times 3 is 9. Now I'm going to change this to a mixed number. I'm going to divide 65 by 9. 9 goes 7 times into 65. 9 times 7 is 63. Subtract to get a remainder of 2. So 8 and 7/9 plus 7 and 2/9. So notice that when I'm adding or subtracting mixed numbers, I leave the mixed numbers alone. It's easier to add that way. So now I have 8 plus 7. I'm going to add the whole numbers, and then I'm going to add the fractions. 8 plus 7 is 15, and when I add these two fractions, I'm counting ninths, so the denominator is the common denominator, and the numerator is 7 plus 2, which is 9. So 15 plus 9/9 is 15 plus 1, which is equal to 16. So notice in this problem, when we were multiplying and dividing mixed numbers, we changed the mixed numbers to improper fractions. But when we were adding and subtracting mixed numbers, it was better to leave the mixed numbers alone and add mixed numbers by adding the whole numbers part of each number and then the fractional part of each number. Here again, we have a similar situation. We have division, which we're going to do first in PEMDAS. So I'm going to go 11 minus, remember, if you have mixed numbers, you have division and multiplication. If you want to multiply or divide, you have to change it to improper fractions. 6 3's are 18 plus 1, 19 over 3 divided by 6 times 1 is 6 plus 1, 7 over 6. So this is equal to 11 minus, and now we still have to do the division. So the only way to divide fractions is by changing division to multiplication and immediately flipping the one fraction right next to it. So this is equal to 11 minus, and I can see there's a common factor, so I'm going to go 19 times 3 times 2 divided by 3 times 7. You cancel common factors and you get 11 minus 19 times 2 is 38 over 7. Now this is easy enough that you could take a common denominator and solve it. Let's just do it that way. And so you multiply the numerator and denominator by 7 for a common denominator. So you have 77 minus 38 over a common denominator of 7. It is 77 minus 38. 8 plus 9 is 17. This becomes a 6. 6 minus 3 is 3. So that's a 39 over 7. And I can change it to a mixed number. 7 goes 5 times into 39. You're dividing by 7, leaving a remainder of 4. So 5 4/7. Now another way of doing this would be the exact same thing up to this point. Okay, so I'm going to write down, I'm going to start there. 11 minus 19 times 2 is 38/7. So I'm going to start there. Now, instead of just taking a common denominator, I could change this 38/7 to a mixed number. 7 times 5 is 35, leaving a remainder of 3. So I get, so this is what I'm doing. 38 is divided by 7. 7 goes 5 times into 35, leaving a remainder of 3, and I get 5 3/7. Now we're going to subtract. We're going to leave the mixed numbers alone and just subtract. So this is the same as 11 minus 5. And then you still have to subtract the 3/7. So 11 minus 5 is 6 minus 3/7. So 5 plus 3/7. So therefore you're subtracting the 5 and you also have to subtract the 3/7. So we borrow a 1. Remember this technique. We borrow a 1, make it a 5, but we have to account for the 1. So it becomes 5 plus 1, which is 6. And now I'm going to subtract the 3/7 from 1. And I'm going to get 5 plus 1 minus 3/7. 1 can be written as 7/7 minus 3/7, because 7/7 is equal to 1. We needed a common denominator. So 5 plus 7 minus 3 is 4 over a common denominator 7. So it's 5 4/7. So two different ways of doing it. Here we kept the mixed fraction form at the end, and here we just took a common denominator. But if the numbers are large, this method is preferable. So let's look at this one. 3 3/5, parentheses first. We're subtracting 2 4/7. Remember the LCM of 5 and 7 is 35, because 5 is 5 to the 1, 7 is 7 to the 1. Pick the largest 5, pick the largest 7, it has to be 35. So we multiply the 5 with the 7, and we multiply the 7 with the 5, and we get 21/35 and 20/35. So now we subtract. 3 minus 2 is 1. 21 minus 20 is 1/35. So that is 1 and 1/35 times 5 5/6. Now the only way to do this is to change the mixed numbers to improper fractions. So that becomes 35 plus 1, 36/35 times 6 5s are 30 plus 5, 35/6. Cancel the 35s. 6 times 6 is a 36. You divide by 6, cancel the 6's, and you get a 6.